Hello, this is a video on stoichiometry and limiting reactants. Um, this is really more of a remedial video for students who are still struggling with those two concepts. This video would not be going over the same way I taught in class or in the videos, right? Make sure you rewatch those videos, and if you still understand, hopefully this will give you another clue. I have another way of kind of talking about stoichiometry, as well as a little fun animation or simulation that help you visualize what's going on when you create something. Okay. So first, I want you to notice that stoichiometry may seem like a foreign and weird and scary concept at first, but all we're doing is we're talking about a chemical equation, right? And a chemical equation is just a recipe, right? What do I mean by that? Well, look, a chemical equation has reactants and has products. Well, what are reactants? Those are your ingredients, right? What are products? Well, that's what you make when something happens or when you do something with the ingredients. Well, what's a recipe? Right? Let's look at a recipe for making sandwiches. Well, what do we have? We have ingredients. We can call these reactants, and we have products, which is what we end up with. We make sandwiches from our ingredients, right? All a chemical equation does is it's a recipe for chemical compounds, right? So we're going to take a step back from stoichiometry real quick and focus on just, using recipes of common household items to help us familiarize with the math first before we get jumping into with chemical compounds, right? Again, stoichiometry, remember the definition is just finding out how much stuff can be made from any starting ingredient, right? It's just you're looking at a recipe, seeing okay, with my amount of bread, how many sandwiches can I make? That's stoichiometry in a nutshell. Okay, so let's start with working with some hypothetical problems. Right? Let's say in a pantry, you go home, you in a pantry, you found 4 slices of bread. Well, how many sandwiches can you make from 4 slices of bread? Right? I understand this recipe of bread and ham is weird, right? For every 2 slices makes three. With 3 slices of ham makes 2 sandwiches. It's weird, but we're gonna go with it. Okay. Well, from this recipe, for every 4 slices of bread, we can make 4 sandwiches. How did you find that out? Well, you may have multiple ways, but I'm gonna use it using dimensional analysis. If you're still struggling on what dimensional analysis is and how to use that properly, go back and watch the dimensional analysis videos. This is not one. I'm not going to go re-explain dimensional analysis. Except for this, you copy down to units and find your conversions. Okay, if you still need additional help, go back in the other videos. Right. So how you would solve this problem is okay. You start with 4 slices of bread. Well, we know in dimensional analysis, you got to put bread on the bottom now to cross out the units. Right. We know in this recipe for every 2 slices of bread we make 2 sandwiches. Remember, that's what the recipe is telling us, right? For every 2 slices of bread, we get 2 sandwiches. That's our conversion. That's our ratio, right? We canceled out our bread, so we're only left with sandwiches, and that's what we want. We want units of sandwiches. We have 4 sandwiches left, or not left, but we can make 4 sandwiches with 4 slices of bread. Okay. Well, let's say instead of uh, just finding 4 slices of bread in our pantry, we found, you know, 3 slices of ham as well. You know. Well, how many sandwiches can we make now with 4 slices of bread and three ham slices? Well, we know 4 slices of bread can make us 4 sandwiches, but how many sandwiches can 3 slices of ham make? Well, you would say one, or sorry, two, but doing the math way, for every 3 slices of ham, we make 2 sandwiches, right? You cancel out the units, so at the end we can only make 2 sandwiches. Okay, so for our ham we can make 2 sandwiches, but with our bread we can make 4. Well, if we have these in our pantry, what's the maximum number of sandwiches we make? 2, right? Because we ran out of bread. Or sorry, we ran out of ham. There's no way to make 4 sandwiches because we just don't have enough ham to do that. We would just be eating bread at the end. We wouldn't be eating sandwiches, right? So let's take a look at the simulation, right? This is essentially what is going on when we're doing these limiting reactant problems, right? So let's say we have some starting amount of, this is a reaction between NH2 or NH3 and CO2, so ammonia and carbon dioxide, make some products. Doesn't matter what they are, right? So here's the bar at the bottom, where it's 0%, saying this reaction hasn't started at all. Okay. But look what happens when I start the reaction, right? We start with a certain number of grams of ammonium and a certain number of grams of carbon dioxide. Note the masses and the moles does not align. Remember, to convert to moles, you gotta use molar mass. It doesn't matter. This is a better visualization of how much stuff there are. Remember, weight is not a good visualization of how much stuff there are. But let's see what happens when we start the reaction, right? As we start the reaction, notice the numbers in our reactant start going down, right? Why is that? Well, they're being used up to make our products. That's why we have some green starting up in our right side. And as we use more and more and more and more product forms. And once we go to 100%, look what happened, right? Can't go over 100%. This is the end of the line. Why? Well, we don't have any more ammonium to work with. We ran out of ammonia. It's gone. How do we use the leftover? We can't. There's no way we can't use that leftover. It's just left sitting there, right? There's nothing else to react it with. That is the purpose of doing our calculation. We're trying to find out which one will run out first to right? So, let's take a little visualization, right? Let's say for our initial amount of 500 grams of our reactant NH3, we can make 811. Let's just do water. We can make 264 grams of. I'm going to erase this real quick. Select. So, in 500 gram of NH3, we can make 264 grams of water. Okay. Right? Because this ingredient ran out first, we can't make any more water, right? That's 100%. It's done. Well, let's say we increase our NH3. Let's say we just have a lot of that now. Okay. What happens at 100%? Well, we ran out of the other ingredient because we added a bunch more. Well, how much can NH4 make? So if we had 722 grams of CO2, we can make 295 grams of water. Right? So these are just our starting ingredients. I just messed around with it a bit. So I was able to find out how much water each of those starting amounts that we can make. Well, from the numbers alone and from the demonstration earlier, if you start with 500 grams of NH3, right, there's no way we can utilize all our CO2 because it can only make 264. We ran out of NH3 afterwards. Right? Our amount of CO2 could have made us 295 grams of water, but we couldn't use all of our CO2 because we ran out of our other ingredient first. This is why when I was talking about calculating 2 stoichiometric questions and find out which one makes the least, this is why. Okay? This is our limiting reactant, right? It's limiting what we can do. So again, let's go back to our sandwich making procedure. Instead of looking at, chemistry, let's say we have let's scale it up a bit. It's a small bakery now. We don't make 1 or 2 sandwiches at a time. You make a couple dozens at a time. So let's say that we have 2 dozen sandwiches, or 2 dozen bread, right? And you have, let's say, 4 dozen ham slices. Okay. How many sandwiches can you make? Well, again, you have to find out how many sandwiches each of those ingredients can make, and find out which one makes the least, because you'll run out of that ingredient first. Right? Remember, from this animation, one of the ingredients will run out first at 100%, so you can't use any of the other. There will be leftovers. Okay. So let's start with our top example, right? We can convert these to individual number pieces of bread. Or why don't we just find how many dozens of sandwiches we can make? Because again, we can make comparisons of dozens of sandwiches to dozens of sandwiches. So let's just say for every 2 dozen bread, we can make 2 dozen sandwiches. How do we know this? Well, our recipe says for every 2 slices of bread, we can make 2 sandwiches. Why don't we just scale it up, right? 2 dozen breads makes us 2 dozen sandwiches. We didn't change anything. We're just scaling up the recipe. We're just making more of it, right? Now our dozens of bread cancel. We're left with dozens of sandwiches. This is a W. So this is saying we can make 2 dozen sandwiches if we have 2 dozen bread starting point. Right? You can convert that to individual sandwiches if you want, but what's the point? Why? Right? This gives us enough information. For the other one, for every 3 dozen ham, gives us 2 dozen sandwiches. Right? For the same reason that we said earlier, ham and sandwiches. Okay, right? The recipe. We just scale it up. Right? Our dozens of ham cancel. We have 4 divided by 3 times 2. Okay, that is 2 2/3, 2.67 dozen sandwiches. So which one can make us more sandwiches? Obviously our supply of ham. But can we utilize all our supply of ham? No, we ran out of bread because that can only make us 2 dozen. After 2 dozen slices of bread, or 2 dozen sandwiches, we ran out of bread. There's no more bread left. That means we have some leftover ham. How do we find out how much ham is left over? You know, as a business, you want to keep track of what your leftovers are. There's a couple way of doing it, and no, you can't just subtract sandwiches. That doesn't tell you anything, right? 2.67 minus 2 doesn't tell you anything, right? 0.67 sandwiches. What does that number mean? Right? Nothing. Right? You can't just subtract your 2 products and hope for the best and get something out of that number. How do you find out how many slices of ham you have left? Take a pause and think about it. Well, why don't we just find how many slices of ham is needed to make 2 dozen sandwiches? Right? You take your 2 dozen sandwiches, and you convert that to how many slices of ham is needed for that. Right? For 2 dozen sandwiches, you need, the ratio was a 2 sandwiches, or 2 dozen sandwiches. Sorry. For 3 dozen slices of ham needed. Right? So the dozen of sandwiches cancel. This is saying we need, 2 divided by 2 times 3. Okay, that's wrong. 2 divided by 2 times 3. We need 3 dozen ham slices to make 2 dozen sandwiches, right? Well, if we start with 4 dozen and we need to use 3 dozen, when we subtract 4 and 3, we're left with 1 dozen slices of ham left. And this number does make sense, right? The reason why we subtract these two, right? This 4 dozen and this 3 dozen makes sense, right? Because this is what we start with. This is what we're going to need to use to make our 2 dozen sandwiches. So our leftover is 1 dozen. Okay. This is essentially calculating stoichiometry. You were able to find out how many sandwiches you're able to make and what your leftover amount is. Okay. Let's take one more step forward. Right? Instead of working in dozens, let's say we're going to be working, upscaling it. We're going to be working in mass, right? Instead of just counting each individual supply that you have, we're going to find out, okay, you put it on a balance, you have this many grams of that substance, or that ingredient, right? So let's say you walk into work one day, and the delivery guy says, hey, you have 500 grams of bread, right? And 600 grams of ham. Well, if as an owner you want to find out how many sandwiches you can make from this, is there a way to do that right now? No, right? Because the recipe tells us 2 slices. It gives us a count, two slices of bread, not 2 pounds of bread or 2 grams of bread. It gives us 2 grams of sandwiches. Right? It's give us a count. So there's no way to do this right now. We're missing some information. Okay. So what we need to do is say, hey, we know that for every 1 dozen package of bread, it weighs 50 grams. For every 1 dozen ham slices, it weighs 75 grams. Okay, right? Does this look familiar? You have a mass over quantity, or grams over moles. This is a prelude to where we're going to get to next. That's our next progression. Okay. So let's work with this first. Right? You have this conversion now. This is like standard. You measured this before. You kind of know what's going on. So from this, you can find out how many slices of bread you have, right? Because we know for every 50 grams, we have 1 dozen slices of bread, right? Remember, the opposites cancel. Well, now we have dozens of bread. Okay. Do we need to convert this to individual number of breads? We can. We can find how many individual number of sandwiches we have. Or we can just say how many dozens of sandwiches we have, right? Because we know for every 2 dozen bread, we get 2 dozen sandwiches. Right? So from this, we can find out, hey, from 500 grams of bread, we can make so 500 divided by 50 times 2 divided by 2. You can make 10 dozen sandwiches from our supply of bread. From our supply of ham, how many sandwiches can we make? Well, we know for every 75 gram of ham, we have 1 dozen slices of ham. And we know for every 3 dozen slices of ham, we make 2 sandwiches. 2 dozen sandwiches, sorry. Right? Remember, these units all cancel because they're opposites to each other. So this is saying with our 600 grams of ham, we can make 5 1/3, 5.33 dozens of sandwiches. So this is our shipment of the day in the morning. Right? At the end of our day, when we use up and try to make as many sandwiches as possible, what's the maximum that we can make? You don't add them together. You can only make 5.33 because we ran out of ham, so we just have a bunch of leftover bread. Right? We can use that for croutons or whatever. We have leftover bread. How do you find out how much leftover bread there is? Well, if you know you made 5.33 dozens of sandwiches, okay, find out how many how much bread you need to make that many number of sandwiches. So if you need for every 2 dozen sandwiches, you need 2 dozen bread. And we know that every 1 dozen bread, it weighs 50 grams. Right? So all of these cancel because they're opposites to each other. So this is saying that we have 5.333 times 2 divided by 2 times 50. We have used 266.67 grams of bread. Well, if we start with 500, we have to subtract that. This is what we start with, minus 266.767 grams. We're left with 233 grams of bread. That's our leftover bread. Right? Because remember, we calculated how much bread we need to make our 5.33 grams, our dozen sandwiches, because that's how much we can make. So if we use that much bread, right? If we use 266.67 grams of bread, we have only 233 left over. Right. So the next progression is pretty easy, right? So if the analogy I made so far, right, is that this is pretty much stoichiometry in a nutshell. This is what you need to do to solve the problems in stoichiometry, right? Replace bread with some compound, right? Replace bread with silver nitrate. Replace ham with I don't know, lead iodide. Replace sandwiches with some compound products, okay? And replace, this will be I don't know, AgCl. This will be I don't know, NaCl. This will be AgNO3. I don't know, something like that. Right? It doesn't matter. Just replace with compounds and replace dozen with mole. Does that look familiar now? So it's now like gram over moles. So instead of 1 dozen bread, it gives us 50 grams. 1 mole gives us 50 grams. Right? This whole calculation where you're working with recipes that it's the exact same procedure as what you would do in stoichiometry. This is just working with units that right? So you need to be able to get used to these types of calculations. Again, this video may be kind of crude, but just hopefully it may be enough. If not, let me know. We'll work on this. Hopefully, I can use this as a way to help you ease into stoichiometry. It doesn't overwhelm you with scientific jargon, with chemical formulas and all that such. Okay. So if you have any other questions, please let me know.